So we will start a new topic in electromagnetic theory or in electromagnetic theory or electrical properties of material, and that is a topic covered in the electrostatic syllabus. That is the phenomena of dielectric materials. Whenever we talk about these dielectric materials and we ask the students during their viva or in examination, I have seen that they are a bit confused. Till now, whatever you have studied in electronics or electrical theory, you have studied that the solids can be classified as conductors and insulators. These are two extremes of the solid state. And you know the basic definition of conductor and insulator, that a conductor has a large number of free electrons that conduct electric current when there is an electric field applied to the conductor. At the other extreme we have insulator, and in between we have these materials called semiconductors that we study in electronics. Now when we are discussing dielectric material, we are concerned about the insulators. We are concerned about the insulators. Dielectric materials are a kind of insulating materials, or you can say that they are insulating materials. But all insulators are not dielectrics. So dielectric material is basically a insulating material. Dielectric material is basically an insulator. Insulator means it has no free electrons. It has no free electrons. And from your standard 12 course, when you study the capacitors, and in BSc, you have seen that you have come across dielectric materials. Examples are water, paraffin, paper. These materials, mica, they are used in capacitors to increase the capacitance. But we have not investigated or we have not studied in detail these materials. So you will study the dielectric material in detail. So they are basically insulators, or in many textbooks they are written as insulators or dielectrics. So conductors, we know that conductors have an unlimited supply of free electrons that conduct current, have an unlimited supply, or sometimes it is said that there is a sea of electrons. In many textbooks you will find this definition: supply of free electrons, or there is a sea of electrons, huge number of free electrons that conduct current when the conductor is subjected to an external electric field. But insulators, they do not have any free electrons. What is meant by free electrons is that all the charges or these electrons, they are attached to specific atoms or molecules, and they are what is said in a tight leash or a tight binding. Their movement is restricted. In the insulators, the free electrons have a restricted movement. They are not free as the electrons in a conductor. In insulators, the electrons are bound to atoms or molecules, and they cannot move freely. Are bound to atoms or molecules, and they cannot execute free motion. They cannot execute free motion. They cannot move freely as it is possible in the conductor. So they are not conducting any current. But, so you will ask, this is the definition of insulators. So what about the dielectrics? The thing is that if they cannot move freely when they are subjected to external electric fields, but it is not that they cannot do any movement. Movement can be of many types. Rotation, vibration, oscillation, they are also movement. What happens in an insulating dielectric? The electrons can do small movements, not away from the atom or molecule to which they are attached. The electrons or charge carriers can move or can perform very small movement, and this is the key aspect. Movement within the system to which they are attached. They may be attached to an atom or within the molecule. Within the atom or molecule, they can perform small movements or molecule. In any case, the charge carriers cannot detach themselves from the atom or molecules. The charge carriers cannot detach themselves from the atom or molecule. This is the key aspect. Now, what type of motion can they do? The small motion, what is this type of small motion? They are microscopic displacements or microscopic movements, and they are not so effective at the whole as the combined movement or rearrangement or displacement of charges in a conductor. But these small microscopic displacements of each each electron, these movements add up so that some characteristic behavior of dielectric materials are produced. So what happens in a dielectric material? In a dielectric material, the small movements of the charge carriers, you can say electrons, charge carriers within the atom add up, which is called a cumulative effect, add up to show the dielectric properties. So if you are required to describe or define a dielectric material in a very short or in a brief manner, you can say in a dielectric, or you can write it this way or say it this way, that dielectric is a kind of insulator. It is a kind of insulator where the charge carriers can perform very small movements within the atom. They cannot detach themselves from the atom or molecule, but still they can perform very small movements. Dielectric materials are such insulators where the electrons, or you can say the charge carriers, because primarily these electrons are the charge carriers because they are light, they are less massive, where the charge carriers can perform small movements within the atom or molecule without getting detached from the atom or molecule. This is dielectric material. They perform motion but keeping themselves attached to the atom or the molecule. Now there are two principal mechanisms by which this motion can occur, and this motion will occur because they are charged particles. They will be influenced by the electric field, external electric field. So what the electric field does, what is the function of the electric field when it is applied to a dielectric, is that the charge distribution of a dielectric atom or molecule, it is distorted. Suppose, let me show you with a rough diagram that this is the positively charged nucleus, and around this nucleus you have a distribution of negative charges. See, this way the negative charges are placed and electric field is zero. Now when the electric field is not equal to zero, what happens? This charge distribution gets distorted in a dielectric material. It is not that the electric field is detaching all the electrons. Suppose this charge distribution becomes like this, asymmetric. This is symmetric charge distribution in the absence of electric field. Symmetric distribution, and in the presence of electric field this becomes asymmetric. So when a dielectric material is placed in an electric field, when a dielectric material is placed or it is subjected to an external field, or it is subjected to an electric field, of course external, the charge distribution in the material gets distorted. Distorted means its shape changes from symmetric to asymmetric. The charge distribution in the material becomes distorted, means it loses its symmetric shape. This is called distortion. This is what occurs in a dielectric material. The electric field distorts the charge distribution inside the material. And the two prominent methods of distortion are stretching and rotation. This charge distribution, this is what you see is a kind of stretch, similar to the situation when you are stretching a spring or stretching an object. The two principal mechanisms by which the charge distribution is distorted, the charge distribution is distorted are stretching and 2 rotation. Means the charge distribution is either stretched or it is rotated. So there are two kinds of motion that are occurring, but you have to remember that all these motions, they are restricted to the atom or the molecule to which the charge is attached. Now how this distortion is occurring, how this distortion takes place, and how this dielectric material behavior can be explained. To understand this, we have to consider the concept of induced charges. Concept of induced charges. What are induced charges? Induced means something which is introduced by an external factor. You must have seen, you must know about induced charges, that if it is a charged body, we study these things in school level. Now suppose if you bring a glass rod which is charged in front of some other object, suppose this is a glass rod and it is positively charged, and you bring it in front of this object which is initially neutral. Neutral means, when you now properly understand what does this neutral means. Neutral means symmetric charge distribution. Symmetric distribution of charge. We are talking about the internal structure, internal distribution of charges. In general, symmetry means there are positive charges are equal to the number of negative charges. Or you can say n plus is equal to n minus. So this is in terms of the discrete charges, that as there are as many positive charges as there are negative charges. Now when you are bringing this positive charge, near this surface you have an induced negative charge. We have studied this thing in the school level, induced negative charge. So this is the concept of induced charges. Now what happens in a dielectric material? What is the concept of dipoles? Induced charges. And next concept that is important is dipoles. This also perhaps you know, I am sure, that you have a positive charge and a negative charge of same magnitude q, and they are separated by a distance d. This is a dipole, and this is a fundamental quantity when you are studying electromagnetic theory. We will see the importance of dipoles later on in this section. Now what happens when you have a neutral atom and you suppose it is a dielectric material? You are putting it in the external electric field. So what will happen if someone asks you, if you put a neutral material, suppose this material is totally neutral, and there is an electric field like this, you are putting this material in an electric field. What happens? A neutral material is placed in an external field, electric field of course. Now what will happen? What will be the effect from inside? Now our first guess is that because the material is neutral, there is no charge in it, neither positive or negative, the field will not affect it, because we have seen that when we place a positive charge in a electric field, it is accelerated towards the positive charge electric field, and if the charge is negative, it will be accelerated in a direction opposite to the field. But since this material is neutral, so there should be no effect. There should be no effect of external field E. But is it so? Now what we mean by neutral is that we have the equal number of positive and negative charges. But that is the situation when we are considering the discrete charges. At the atomic level, what we have is a positively charged core, which is the nucleus, and we have a negatively charged electrons that are surrounding the nucleus. Now these two regions, one of positive charge and the other of negative charge, they are influenced or affected by the electric field in opposite ways or in opposite directions. So at the atomic level, what we have a nucleus and we have a cloud of electrons that are surrounding this nucleus. When you are applying this electric field, the nucleus, which is positively charged, positive charge, and the electron cloud, negative charge, are affected in opposite manners, by the field. When you are applying this electric field in the right direction, the nucleus will be accelerated in this direction and the electron will be accelerated in the opposite directions. The nucleus and the electrons accelerated, or you can say affected by the field in opposite directions. Now what does this effect cause in the overall material? This is the phenomena that is occurring. Now if you have a very strong field, very strong electric field, what will happen? That the electrons may get totally detached from the nucleus, which we call a process called ionization or ionizing, and this all happens with the valence electrons, and this electron becomes free and the material becomes a conductor. So for very strong field, what will happen? This is the nucleus, and if you have these electrons attached, and this is the direction of field, the electrons are accelerated in the opposite direction. At a certain situation, the electron may get detached from the nucleus and it will become free. So the atom will be ionized and there will be free electrons. So the neutral material, it is becoming a conductor. At strong values of electric fields, the electron, because the nucleus is quite massive, may get detached, resulting in ionization of atom. The neutral atom is no longer neutral. It is getting a positive charge because one negative charge is lost, and a free electron is produced. And this free electron is capable of conducting the electric current. So what was an insulator at strong values of electric field, it is becoming a conductor. This is the transformation that is occurring, and of course the fields required are very high. This is one extreme, that the total system is changing, and at the zero electric field the material is neutral. But what happens when the electric field is in between the very high value and zero value? In that situation, the situation is very interesting. And what happens at medium electric fields, there is an equilibrium which is established. In that case, the center of masses or the centers of the negative and the positive charges are become separated from each other. And what happens is still the electrons do not lose the contact with the nucleus. So there are separate regions of positive and negative charge. At medium values of electric field, medium values, this is a very interesting situation. I will describe this. This is called breakdown. At medium values of electric field, what happens in a material, that suppose if you have this material and there are two regions that are developed. This is one region where there are positive charges, and suppose this is the center of the positive charge, and the other region is of negative charge, and suppose this is the center of the negative charge. And now these two charges, they are attracting each other. There are separate regions of positive and negative charges that attract each other. Now what happens, it is still that the electrons are not detached. You have to keep this in mind. This is not the extreme electric field. Electrons are not still detached from the atom, but they are separated. There is a separation between the positive and negative charges, and still an attractive force is acting between them. Now in this situation we have an equilibrium developed. Since there is a force of attraction, let me write this as EI, and we have an external electric field. Suppose this is E. This is E. So what happens? An equilibrium is formed between two electric fields, because now inside the material you have an electric field which is due to the force of attraction between the positive and the negative charges that are formed due to separation. An equilibrium is formed between the external field, suppose this is E external, between the external field E external and an internal field E internal, due to separation of charges. This equilibrium is formed. This is the speciality. And at the equilibrium situation, these two electric fields, they balance each other. Means E external is equal to E internal at equilibrium. At equilibrium, they are balancing each other. The two opposing forces, the pulling of electrons and the nucleus apart, at their mutual attraction brings them back together. So what you have, this external field, it is separating the two electrons, and this internal field, this is trying to bring them back together. So they have opposite effects, and at equilibrium they balance each other. This is the most important phenomenon. Now what is the result of this phenomena? The result is that When the plus charges are shifted slightly from the minus charge, the system becomes polarized. The net effect is that due to external field, the atom, the positive and negative charges that were together in the absence of field, in the absence of field, are now separated from each other, of course by a small amount from each other. So the insulating material is said to be polarized. Polarization you have studied in optics also. Polarization means asymmetric behavior. Polarized. So let me try to show you by a diagram. If this was the neutral material, so these are the positive charges, these are the negative charges. Let me show them by different ink. This is negative charge, this is negative charge, this is negative charge. Or you can say, if this is the center of mass of the negative charge and if it is the center of mass of the positive charge, they were together in a neutral material. Now when the material is polarized, the center of mass of the positive charge is shifted, or it is separate from the center of mass of the negative charge, and an attractive force is acting between them. So the external field has separated the positive and negative charges, or it has created a separation or difference between the positive and negative charges, and this material is said to be polarized. Polarized materials have positive and negative charges separated from each other, separated from each other. This is the difference between, this is the phenomena that is occurring. And this polarization, so what is happening? The material, the neutral material was a neutral material because the center of masses of the positive and negative charges were together. Now what happens at the microscopic level in the polarized material, there is a development of a dipole. Means equal amount of positive and negative charges are separated by some amount. At the microscopic level, there is the formation of a dipole. So if this is a polarized material, this is the region of positive charge, and slightly at a slight distance from it, it is the negative charge region. So it is a dipole, microscopic dipole. This is called polarization. That happens in a dielectric material. Now every dipole has a tiny dipole moment which points in the same direction as the electric field. This dipole moment of the system or in the polarized material is proportional to the electric field E. The dipole moment E is proportional to the applied field, the amount of field or the magnitude of the field applied to the proportional to the external field. The more field you apply, the more separation occurs, and at very high values of electric field, the negative charges and positive charges will be detached from each other, resulting in breakdown. That is a topic I will discuss later. Is proportional to external field. So what we can write mathematically, that P is proportional to electric field, and when we remove this proportionality sign, we put a constant alpha. This is proportionality, this is alpha. They are looking same, so please don't get confused. Alpha E, and this alpha is called atomic polarizability, which is a very important factor in dielectric materials. Alpha is called atomic polarizability. Atomic polarizability. So in the next section, we will go into the details of this topic and see the concept of induced dipoles and other features of the dielectric material and the problems related to dielectric materials. So for the time being, stay tuned. Please subscribe the channel, like and share the videos. And if you have any queries, please ask in the comment section. Thank you.